Alright, so we're going to talk now about significant figures. In science, the number of digits that you write is going to indicate the uncertainty of the measurement. For example, if you say something is 2 centimeters or you say something is 2.00 centimeter, in science, those two have very different meanings. Something that is 2 centimeters, maybe you use a finger to measure it. Something that is 2.00 centimeter, you use a more precise instrument to measure it. More significant digits that we use, more precise the instrument that we use for that measurement. Measure numbers are obtained using a measuring instrument. And there is always an uncertainty associated with a measurement. Exact numbers are numbers that are obtained by counting. And these numbers have no uncertainty. For example, if I say 2 baseballs, that is an exact number. Another thing that is an exact number are defined equalities. For example, 1 foot is equal to 12 inches. That is also considered an exact number. So let's do this problem together. We're going to write E for an exact number and M for a measurement. Gold melts at 1064 Celsius. How do we obtain this? By using a thermometer. Therefore, this is going to be a measurement. 1 yard equals 3 feet. That is considered an exact number. The diameter of a red blood cell is equal to this many centimeters. Therefore, we use this is a measurement. There are 6 hats on the shelf. This is an exact number. And a can of soda contains 355 milliliters. This is a measurement. Please notice that for the measurements, the number is followed by a unit, most of the cases. And for exact numbers, it's things that you just count. What we do when we read from an instrument, we take a look of the scale. Then we're going to determine the last digit by estimated between the marks. So what we do is we mentally divide this gap into tenths, and then we make a prediction of where that will be. So let's take a look of this ruler. This ruler is in centimeters. We see that this is 1 centimeter, correct? So this is half, this is 0.5 centimeters. The smallest mark that you can read here will be 0.1 centimeters. What do you do with that? You divide that by 10. That gives you 0.01 centimeters. Therefore, when you are giving your measurement out of these, what you do, you have to report with 2 decimal places. So let's read this together again. This ruler, this piece of wood that we're measuring here with the ruler, is 4.5. Now, is it 50? No, it doesn't fall straight into this line. So what are we going to do? We look into this, and we mentally divide it by 10. And when we read it, we could say maybe 4.55 centimeters. So again, what you do, you look at the smallest reading. In this case, it's going to be 0.1, and what you always do is divide it by 10. This will give you 0.01. That means that all your readings are going to have 2 decimal places. So let's take a look of this problem. What is the smallest reading that we see? The smallest reading is 1 centimeter. We divide that by 10. That gives us 0.1. So what we read out of this ruler will only have 1 decimal place. So for example, this piece of wood will be 4.3 centimeters. It's okay if somebody say 4.4. It's okay if somebody say 4.5. What is not okay is someone saying 4.35, because that means that we had a different ruler. In this case, again, the smallest mark that we see is 1. We divide that by 10, that gives us 0.1. Now, our reading is going to have only one decimal place. So, this piece of wood is 3.0 centimeters. When we have a gravity cylinder, we see that we have what is called a meniscus. It looks like that. So it's not the same reading if we read it here that if we read here. So we always take a look of the bottom of the meniscus, and that is where we are going to read. There are certain rules when we are dealing with significant figures. For example, when we have zeros that are before non-zero digits, they are only there to tell you where to put the decimal place. So in this case, we only have 3 significant figures. This 0 over here is after a non-zero digit. Therefore, that 0 is significant. This number, we have a decimal place right here. The zeros to the right, to the left, and the zeros to the right are going to be significant. Therefore, this number has 5 significant figures. When we don't know where the decimal place is, we assume that those zeros are not significant. So, for example, in this number, where is the decimal place? You don't know. Therefore, this number has only 2 significant figures. Where is the decimal place here? We don't know. Therefore, this number has only 3 significant figures. When we're doing scientific notation, remember we mentioned before that we had to have a coefficient that goes between 1 and 9.9999. So what we have to do is in this coefficient, we are going to include all the significant figures. So for example, let's take a look of this. This number over here, we have the decimal place right there. Therefore, all these zeros are significant. So when we write our scientific notation in our coefficient, we're going to include all the sig figs. So it will be 5.000 times 10 to the third. If we have it written like this, where is the decimal place? Well, it's not showing. So how many sig figs do we have? Only 1. So you will write 5 times 10 to the third. So let's do this problem together. How many sig figs do we have here? Well, in this case, we only have 3. In this case, only 2. Here, we'll have 3. And in here, we'll have